In this first module of understanding the agrobiology of agrochemical formulations, we will consider the applied aspects of herbicide formulation. In this module, we will cover herbicide formulation and adjuvant options, which we will see are based on the active ingredient characteristics, their solubility, the targets, the target crops, the target weeds, and selectivity among grasses and broadleaves. So we will be looking at differences in physiology and how we can utilize these to develop and expand formulation strategies. We will consider the uptake of the active ingredient, whether it is foliar or via the shoots and roots, translocation of the active ingredient, whether the active ingredient is a contact active ingredient or systemic, in other words, whether it moves through the xylem and the phloem. And we will integrate some of what we learned in the first course on agrobiology of formulations, the Bromelo diagram and the expanded version of the Bromelo diagram. We will learn also about the site of action of herbicidal active ingredients and whether these are in the chloroplast, so in the lipophilic environment of the chloroplast, in the cytosol, or in the cell wall. And we will learn about the mode of action of key active ingredients and associate these with expected symptoms. The active ingredients on this basis will be grouped into classes based on their solubility, on their uptake, translocation, and site of action. And we will see ultimately that herbicide formulation and adjuvant strategies depend on whether the target is to improve aqueous or lipophilic solubility and uptake, or for soil application. With regard to these, we will consider options for optimization of active ingredients, formulation, and adjuvant choices for aqueous solubility, so essentially for the hydrophilic active ingredients, and optimization for lipophilic uptake for the lipophilic herbicides. In addition, we will consider the special challenges and opportunities within high electrolyte systems for herbicide formulation, as well as optimization options for these systems. And we will align essentially all of the information and input which we cover in this course into some overview references where we combine the model we will build up on the active ingredient mode of action primarily within the chloroplast, but within plant cells. And we will be looking for overall trends and groupings and basic predictions that we can make on these groups of active ingredients. So we draw this information from available online resources, databases, etc., to give us a tool to allow us to predict which options will be most relevant for specific types of active ingredients. Finally, we will end this module with some case studies, so really bringing the application aspect in with regard to optimization and formulation and adjuvant options. So we have some case studies here where we start by looking at cationic herbicides, opportunities and challenges, with the example of paraquat. We will look at triketones, which are weak acids which may be optimized for aqueous solubility or for lipophilic uptake. We will consider two anionic herbicides, glyphosate and glufosinate, and their respective challenges and opportunities, as well as where the market is going with regard to formulation and adjuvant development. We will consider an active ingredient which is formulated as an ester to increase leaf uptake, and once inside the leaf, the ester is converted to metabolized to the active acid form, which is far more systemic and provides systemic benefits. So this is an introduction really also to the concept of propesticides. And finally, we will consider active ingredients which are volatile, such as dicamba and clomazone, and how we can address the issues of volatility using adjuvant and formulation options. We'll also consider bixlozone, which is not volatile, and how to differentiate between volatile active ingredients, non-volatile active ingredients, and the risk of drift and herbicidal contamination of neighboring fields.